This video is part 1 in a 2-part series on how to find functions in Geometry Dash. This part will specifically cover Geometry Dash for Windows, along with setting up the general environment, which will be needed for part 2, which will cover Geometry Dash for macOS. In this video, there are 4 methods used to find function addresses in Geometry Dash for Windows. But to get there, you need a good setup. First, you will need to install the Java runtime environment. I recommend you install it from this website, which I will link in the description, but you can also install it from oracle.com if you want to. I won't go too in depth with the installation because I already installed it. So next, you'll need to download Ghidra from this GitHub repository. Then once you open the zip file, you can extract it to your downloads folder. Then after you extract it, you can run ghidra run.bat to open Ghidra, or you can just run ghidra run if you're not on Windows. Once you open Ghidra, you can go ahead and download the Geometry Dash binaries from the MediaFire link, which is in the description. We will be focusing on these 3 files for now. After you extract the binaries, you can create a new Ghidra project. Then you can drag these files into your Ghidra project. You can also click File. You can also click File, Import File to import your files, or you can press I, but I usually prefer to just drag them in. Now that we have these binaries in the project, you can go ahead and open them and start analyzing them. Keep in mind that this could take upwards of 30 minutes to finish, but when it's done, it'll be worth it. After all 3 of these files have finished analyzing, you can download the Geode SDK bindings, and then you can unzip it. On the window with the Windows binary, you can click this Script Manager button, and you can manage the script directories. And then what you will do is you locate the binding scripts. Since I already have these scripts added, I won't keep this. What next you will do is you will run sync Broma script, click proceed anyway, uncheck sync members and export to Broma. Then you click geometry-dash.bro with 2.2074, which is the version that I'm using right now. If you're watching this in the future and there's a new Geometry Dash version, you would choose the version that you are using for this binary. So you then click OK. Now you could just manually overwrite or merge some of these, but for all intents and purposes, I'm going to click overwrite all. Now that we've imported our functions, we can get into the 4 methods for finding function addresses. I thought I'd also let you know about the potential dangers that come up with finding these functions. I'll list them on screen. The reference method usually involves finding references to new methods from already found methods. I forgot to talk about how to open this menu and use it. So basically what you do is you press G and then you type in either the name of the function or the fully qualified function name. take these three methods from editor UI key down, for example. We want to find these methods' names. And so we can go to the same place on 64-bit Android based on some pre-existing conditions like this offset, like these little offsets in the structure. So we can determine this function right here as on target ID change. This part is the address. Ignore the 140 and all that. That's just the leading, the header address. So if you subtract the header address, you'll get this address, meaning that this is the address for editor UI on target ID change. Be sure to check if the body of the function matches, because sometimes it won't match. But there is some platform specific code in a few functions, but we're not going to focus on that now. And as we can see, we found a lot of other references, like this reference to game object is trigger. But this function, affect game object set target ID, is where the compiler really comes into play. This function is automatically inlined, meaning that the function call is replaced with the code of the function. When that happens, the function, if it exists at all, loses a reference. If a function is not being referenced at all, then the function gets deleted and is therefore unfindable. This is the importance of being careful when you're finding these bindings. I originally recorded that part for the showcase for the string method, but I later on realized that was not a good example, so here I will show you a proper example that is not found. This one, game level manager, get gauntlet levels. You can see that this string, you could use a lot of strings in here. Like this one, gauntlet equals, or this base 64 encrypted string. I'm going to use gauntlet equals since it will be a bit easier. The less references, the better. So if you go over here, you'll discover that this is the method for game manager, get gauntlet levels. We can also do get gauntlets too. Look at this, get underscore gauntlets. Or we can do this one, and secret and special right here. And so this would be get gauntlets. The table method involves using virtual function tables to locate functions based on relative location of other found functions. Like for example, if we want to find song trigger game object, get save string, then we can go to the main v table. We will be looking for the one that starts with copy with zone. This one, It's a pretty long vtable, so I'm gonna have to scroll down a bit. Now, as you can see, custom object setup and get save string are right next to claimed particle and unclaimed particle. So what we can deduce from this is that this is custom object setup and this is get save string. The table method is very useful when you want to find the address of a virtual function. You just look up the relative location in the Android virtual function table, and then you compare it to Windows, and you find those addresses accordingly, being sure to check. But remember that if the function actually belongs to a different class, it's very likely that the virtual function is merged, being that it has the same code, so it becomes one singular function. So be careful with those. I usually only use the neighbor method when it's like a relatively small class, because if it's large, then it's gonna be like barely tolerable to do them all, you know. A good example to use the neighbor method would be edit level layer scene. And so you can go to this address, right click, expand all data, then you can see some of the missing edit level layer methods. We're gonna focus on these two, for example. Like this one, you see a string in here. This one here just creates this. So we can look for references to game level options layer, create, and we can see that this is edit level layer on level options. Now the other one. Which one is this? Which instances of a level leaderboard create are there? We see edit level layer on level leaderboard. Layer on level leaderboard. Also, be sure to check if your bindings are correct, because you never know. The easiest way is to compare both of them. They seem about right. But that's enough for me. What I'd suggest you do is create your own fork of Geode SDK bindings, add your own bindings, and contribute by opening a pull request. I'll see you then.